As an introduction today, consider this possibility. There's a couple, they want to have one kid. Can you see that there's two possibilities of what they might get? They might get a boy or a girl. There's a 1/2 chance that either possibility is going to be the one that happens. What if they have two kids? Can you see that there's 3 possibilities? They could either have 2 boys, 1 boy, 1 girl, or they could have 2 girls. Can you see that there's only one way for them to get 2 boys? They'd have to have boy and then a boy. But there's 2 ways for them to get 1 boy, 1 girl. They could have a boy and then a girl, or they could have a girl and then a boy. That's why there's 2 possibilities, or 2 different ways of getting this possibility. Here, they have to have a girl and then another girl, so only one. Okay? That means that they have a 1/4 chance of getting 2 boys, a 2/4 chance of getting a boy and a girl, and just a 1/4 chance of getting 2 girls. Look at this one. If they have 3 kids, there's really 4 possibilities. They could have 3 boys, 2 boys, 1 girl, 1 boy, 2 girls, or 3 girls. Okay? There's only one way that they could get 3 boys. They'd have to have boy, boy, boy. All right, there are 3 different ways that you could get 2 boys and 1 girl. Look up here. It could go boy, boy, then a girl. It could be boy, girl, boy. Or it could be girl, boy, boy. Right? That's where that number 3 comes from. Similar on these ones. Compare what we just did to what happens when we expand a binomial. This is a binomial. B plus G to the first power is just B plus G. That's easy. What's B plus G squared? That's B squared plus 2BG plus G squared. You could FOIL that to get that answer. Does this look familiar to you? Those numbers right there, do you see those numbers in here? Those are the coefficients. Let's do this similarly. B plus G cubed is B cubed plus 3B squared G plus 3BG squared plus G cubed. Once again, do you see these numbers in here? Coefficients. What else do you know about this? Do you notice? Do you notice that the coefficients of the B are getting smaller? The coefficient here is 3. Here it's 2. Here it's 1. Here there's a B to the 0 power, but we don't put it because anything to the 0 power is just 1. Okay. This is Pascal's triangle. I put a 1 here. Second line is also a 1. In Pascal's triangle, the outside terms are always 1. Okay. Down here, I've got 1 and 1, but instead of, you know what, I'm going to change this just a little bit. I'm going to move this down. Okay. I need a third term, and I get that by adding the 2 above. Good? Look what happens here. I put 1s on the outside. I need 4 terms altogether. I get the middle ones by adding the 2 above. 1 plus 2 is 3. 2 plus 1 is 3. Do you see that 1, 3, 3, 1 right here? That 1, 2, 1 right here? That 1, 1 right here? Okay. Today is all about looking for patterns. All right, let us go through making Pascal's triangle in a bigger way. How do you make Pascal's triangle? Again, you start with a 1, put 1s on the outside, put 1s on the outside again. Middle term, I need 2. 1 plus 1 is 2. Next line, I need 4 terms. I put 1s on the outside. The middle terms come from adding. I add. Next line needs 5 terms. I put 1s on the outside. Here I end up with 4. Here I end up with 6. Here I end up with 4. Next line, 1, 1, 5, 10, 10, 5. I'm adding 4 plus 1. I'm adding 6 plus 4. Next line, 1 and 1. 1 plus 5 is 6. 15, 20. Are you seeing the pattern here? Okay, this is really helpful to you. This is going to help us to expand binomials. This very top line right here, this is going to give us the coefficients if we take x plus y to the 0 power. Because anything to the 0 power is just 1. This is going to help us if we take x plus y to the first power. I'm going to end up with 1x and 1y. Those are the coefficients. These are the coefficients if I take x plus y to the second power. These are the coefficients if I have x plus y to the third power. Do you see the pattern? Okay. Each line corresponds with the next binomial expansion. Okay. What other patterns do you notice here? You should notice that the first coefficient is always a 1, and the last coefficient is always a 1. The second coefficient relates to the number that we're expanding by, the exponent. So the second coefficient is always the exponent. If I take x plus y cubed, the second coefficient is a 3. That helps us know what line we're going to need. Notice also that it's always symmetric. That's going to help us have half as much work. Watch me do this one. B plus g to the 5th. First of all, which line am I going to need? Okay, I'm going to need this one. Okay. If I have b plus g to the 5th, that means I'm going to have 6 terms altogether. I know the first coefficient's 1 and the second one is going to be a 5, which is going to match. Okay? So here's what I do. I'm going to take the first coefficient, 1, and I'm going to multiply by b to the 5th and g to the 0 power. But g to the 0 power is just 1, so I don't actually have to write multiplied by 1. Okay. Now I take the second coefficient. I add 5. I'm going to say b to the, I'm going to decrease the exponent by 1, b to the 4th, g to the first power, or just g. Now I'm going to take the third coefficient, 10 times b to the third power, g squared. What do you notice about the exponents of the b's? Going down. How about the exponents of the g's? Going up. Next coefficient is 10. I say b squared, g cubed. Now I keep going. Next coefficient is 5. B. Okay, now I'm down to just b to the first power. I can just leave that as b times g to the 4th power plus last coefficient, 1 g to the 5th power. You notice it's symmetric. The exponents of the b's are decreasing. The exponents of the g's are increasing from 0 to 5. And my coefficients came from Pascal's triangle. Let's try this one. I'm going to pause the video, write the answers down so you can try it on your own and then compare it to me. All right, compare your answer to what I got. Let's move on. All right, I am going to go ahead and try this one. Okay. What's different here is now you have a subtraction sign. So what I'd like you to do is do the same thing, but imagine that this is plus negative 1 to the 6th power. Okay. Watch me do the first couple, and then I'll pause the video so you can finish the rest. We know that this is going to be our line that we're working with. So our first coefficient is 1. We're going to do x to the 6th. Okay. Now I'm going to add 6, x to the 5th, negative 1 to the 1st power, plus 15 x to the fourth negative 1 squared. Do you see how my negative 1 becomes my second part of the binomial expansion? This is just the beginning, okay? So I'm going to go ahead and pause the video. I'm going to write it all out, and then we're going to talk about simplifying each term.
Sorry, I'm late. I want to listen to that.
Uh-huh.
So someone doesn't matter. Stop by, say hi. There was such a crowd that it took a while to actually get
I
up.
had a feeling there might be.
Yeah. I'm here. I should. Are you here for a second?
I am. I'm actually recording. Not a particular second, but.
I'm gonna go see if I can find my coach.
Okay. Do you have your stuff? Yeah.
Most of the doors are locked. I saw one door was open.
It's locked already?
It's not still open. By the time I come back again,
Just text
if
me.
you hear, I don't know how, but if you hear like if you hear a phone call from a random person, it's probably me.
Okay. All right. See if you got the same answers that I did. And now we need to simplify each term. This, we can just leave off the 1. We can just call that x to the 6th. Look what happens here with the second term, though. Okay? You've got 6x to the 5th multiplied by negative 1. Wouldn't that be simpler just to write it as minus 6x to the 5th? How about this term? I've got negative 1 squared. That's going to become 1. So I can just say this is 15x to the 4th. Okay? Look what happens down here. This becomes negative 1. Right? So I can just say that that's minus 20x cubed. This becomes positive 1 plus 15x squared minus 6x plus 1. Let's try this one over here. Similarly, just like we had negative 1, this time we've got 2x as our first term. So watch the first couple. I'm using this line. I'm going to use 1 times 2x to the 4th. Okay, make sure you put that in parentheses. Plus 4 times 2x cubed times y. You see the pattern now? Let me do one more. 6 times 2x squared, y squared. Now you keep going on by yourself while I pause the video. Okay? All right, notice this is what I have. We still need to simplify. So I'm going to pause the video again and show you the simplification. All right, here's what I got when I simplified it. Notice that you have to, when you take the 4th power, you have to take the 4th power of the 2 and the x, right? Similarly, for this term, you have to take the cube root of 2, that's 8, not the cube root of 8. You have to cube 2, get 8, then multiply by the coefficient to get 32. Okay? All right, now we're going to do binomial theorem, a shorter and even cooler way to expand a binomial. Okay? Watch the first bit of it. First, we begin with, I'm just going to put the variables out first. So you can just watch this strategy. See how I'm just putting the variables, and I'm going to put the coefficients in a little later. I'm going to put the coefficients in without using Pascal's triangle at all. Okay? I'm just following the pattern. B times the 4th, b to the 5th. Now watch what I do with the coefficients. Oh, I'm going to run out of time. So you'll have to go to part 2.